So this is the Test 7 review. I will pick out a few and do these so that you can see some examples. So the first one is graphing, so solving a system of equations by graphing. We have two equations. We have the first equation and we have a second equation. So the first equation, we want to first solve for y. So we have negative 6x plus 2y is equal to negative 4. So we would start by moving the 6x over with addition. That would give us 2y is equal to 6x minus 4. And then we would divide everything by 2. So we would get y equals 3x minus 2. So remember that the number at the end, this negative 2, is our y-intercept, and the number in front of the x, the 3, is the slope. So we would use that to graph. So we would go to negative 2 on the y-axis and make a dot. And then we would use the 3, so we would go 1, 2, 3 up and run 1. So it's 3 over 1. So 1, 2, 3, run 1. And of course, I think on your end on the computer, you would just have to do this to make 2 dots, right? And then it would connect them for you. So there is the graph of the first line. The second line, we'll do the same thing. We'll solve for y. So we have 3x minus y is equal to negative 1. So we would start by trying to get the y by itself. So we would move the x piece by subtracting it from both sides. So we'll have negative y is equal to negative 3x minus 1. We would need to divide everything by that negative 1. So we would have y equals 3x plus 1. So our y-intercept is 1, and our slope is 3. So let's graph that line. We have 1 is the y-intercept, and the slope 1, 2, 3, 1. 1, 2, 3, 1. So we rise 3, run 1. Notice that the slope from this equation is the same as the first equation. If the slopes are the same and the y-intercepts are different, then these lines will never intersect because they're parallel. So the solution does not exist. So for our solution, we would put D and E as indicated in the directions, and that would be the graph. Remember, the solution of a system of equations is where it intersects. So if they're parallel, it doesn't intersect, so there's no solution. Okay, so these are all solve the following system of equations with elimination method and write your answer. So you've got 1, 2, 3, 4 of these in number 2. Let's just pick one, and we'll do one of these together, and then you can do the rest in the same way. So let's just go ahead and I guess pick the first one for no reason other than it's the first one. So if I'm going to pick the first one, I notice that for the 9 and the 18, the 9 and the negative 18 for x, if I just multiply the top equation by 2, 9 times 2 is 18, and that's the opposite of the bottom, which is negative 18. So I'm going to do that. When I do that, I will have 18x plus 4y is equal to negative 44. Remember to distribute that 2 to all the pieces of the entire equation on both sides. And then the bottom equation would stay the same, so we would have negative 18x plus 4y is equal to 28. And now I'm going to add these equations together. Because my x's are opposites, they will cancel out. And I will have 8y is equal to, what is that, negative 16, I believe. We'll finish solving for y by dividing both sides by 8. So we'll have y equals negative 2. Now remember, for these, once you find one of the variables, then you plug it in and find the other. So we found the y. So y is negative 2. So I'm going to plug that in. I'm going to pick the top equation, but you could use either one. So 9x plus 2y, y is negative 2, so I'm plugging that in, equals negative 22. So this is 9x minus 4 is equal to negative 22. I would add 4 to both sides. So we get 9x equals negative 18. Divide by 9. So we get x equals negative 2. So x and y, actually you found both of them to be the same. So our ordered pair, remember that you put it in x first, y second. So our ordered pair solution here is negative 2, negative 2. You would do this same process for the other parts of number 2. So let's move on to number 3. Okay, so below are the graphs of 3 systems of equations. I'm going to let y'all do that one. Number 4. So this is just asking you for the size of the matrix. Remember that you're looking at rows by columns. So the first number should always be the number of rows, which is going this way. Right? And the second number should be representing the number of columns, which is up and down, going this way. So in this example, we have 1, 2, 3, 4, 5 rows, and we have 1, 2 columns. So this would be a 5 by 2 matrix. Number 5, write the system of equations as an augmented matrix. So this is just writing the augmented matrix. So remember that each equation gets a row, and each variable gets a column. So you want to make sure that all of your variables are lined up. So you can see that D is first, U is second, M is third, and then your answer is last. So those are all lined up together. So we're ready to go ahead and write the augmented matrix. So we'll have 3, 2, 1 as our first column. Then we have 1, 2, negative 2, 4 as our second column. Negative 4, negative 1, 6 as our third column. We have our line indicating the solutions on the other side. Negative 3, negative 31, and 164 is our last column, and that would be our augmented matrix, and that's all it's asking us to do there. Number 6, perform the indicated row operations on the given augmented matrix. So our augmented matrix is here. Our line would be there. It's always right before the last column. Multiply row 1 by row 4. So multiply row 1 by row or by 4. Okay, so that would be 4 times row 1 is negative 4, 3, negative 6, negative 6. And so we would multiply that and we would get negative 16, 12, negative 24, negative 24. So for part A, we would get negative 16, 12, negative 24, negative 24. And I don't know, it has a blank here, so I'm not sure if you're just writing that row in, because sometimes when I download this, it doesn't copy appropriately. So I'm not sure if you just put that row in or if you put the whole matrix in. If you put the whole matrix in, remember that you're only changing row 1 and you're not changing row 2 or row 3 for part A. For part B, you're just interchanging row 2 and row 3. So row 1 would stay the same, negative 4, 3, negative 6, negative 6, and then row 3 becomes row 2, so 6, negative 1, negative 5, negative 1, and row 2 becomes row 3, so negative 2, 3, negative 4, 3, and that's it. And then part C, multiply row 3 by negative 3 and add to row 1. So negative 3 times row 3 plus row 1. And we're going to replace row 1, whatever you're adding to. So if we're adding it to row 1, then we're replacing row 1 with that sum. So let's see what we get there. Give myself a little more room. Okay, so -3 times row 3 is, whoops, not -6, just 6, -1, -5, -1. So that's going to give us -18, 3, 15, 3. Okay, so that's that. Whoops, I don't need that. Okay, and then I want to add that to row 1. So row 1 is -4, 3, -6, -6. So when I add that, I get -22, 6, 9, -3. And that will become my new row 1. So if I needed to write the whole matrix again, I would replace row 1 with what I just found. And then I would just copy row 2 and row 3. And that would be my answer for that matrix. Okay, the next one, what row operation will transform the first matrix into the second matrix? I'm going to let you all figure that one out on your own. I'm going to skip that one. Number 8, given the matrices A and B, they want to know if it's possible to add these matrices. So in order to add, they have to be the same size. These are both 3 by 3 matrices, so it is possible. And part B, so let's see, it is possible. And then part B is just to add them. So remember, you're just adding the like entries. So -3 plus a -4 would be a -7. -3 plus -2 would be -5. And then -5 plus -1 is -6. So that would be the first row. And I'm going to leave the second and the third row for you to do. But you would do it the same way. You just add the corresponding entries of each matrix. Number 9, given A, compute -4 times A. So in this case, you're just multiplying each entry by -4. So 1 times -4 is -4. 5 times -4 is -20. -16, +20. That would be the answer for that one. So you're just multiplying each entry in the matrix A by -4. Let's move on to number 10. Number 10, we want to do 4 times matrix F minus 3 times matrix A. So we would multiply all of matrix F, each entry, by 4. And then we would multiply each entry in matrix A. I would multiply by -3 and then add the corresponding entries. So let me just do the first row. If I was going to do the first row, multiplying everything in F by 4, I'm going to do it down here. I guess I don't need to have it that big, but it would be -8, 24, -20, 40, and 32. Okay, and then you would do the same for the other rows. So you'd have 3 more rows that you multiply everything by 4. And then I'm going to add, because I'm going to multiply -3 by everything in A. So -3 times each element. Okay, so if I'm just doing the first row for you for an example, I would have 12, -18, 9, -30, and 6. And then again, I would multiply all the other 3 rows, each element by -3. And then since I multiplied by a -3, I'm adding the numbers in, or the corresponding entries. So my sum for my first row, I would just be adding those up. So let's see, I would have -8 plus 12 is 4, 24 and -18 is 6, -20 and 9 is -11, 40 and -30 is 10, and 32 and 6 is 38. And so that would be the answer for the first row. And then you would do the same thing for the other 3 rows. You would add them, the corresponding entries, and that would be your solution for number 10. Number 11, use the Gauss-Jordan elimination method to solve the system. Following the steps outlined below, show all operations and steps on your paper. So you want to make sure that you're following these steps and doing each row operation. Let's see, let's look at number 11, or number 12. Okay, so number 11, I'm going to leave that one to you. It's a smaller one. This is only a 2 by 3 matrix, and it has your kind of a directions or roadmap there. So I'm going to do number 12 for you instead because it doesn't. This is just leaving it all up to you. So let's do number 12 together instead of number 11. Okay, so number 12. First of all, if you didn't want to use Gaussian elimination or the Gauss-Jordan method, there is an option here. As long as you can do the following. If you can write this as an augmented matrix, so that I know that you can at least do that, so that'll be 15, 6, negative 6, 10, 7, negative 4, 3, 1, negative 1, and then 13, 0, negative 6. You can solve using the Gauss-Jordan method. However, if you would rather use the elimination or substitution method, I would use the elimination method on this and find your answer that way. I'm okay with you doing that as long as you provide the work. So if you like using elimination instead of doing the Gauss-Jordan method, as long as you show all of your work, I will not deduct credit. Because both of those are good ways to solve this problem. And this class doesn't focus, this is not a linear algebra class. This is a college algebra class. So if you can use an algebraic technique to solve this problem, I'm okay with that, provided you at least write the augmented matrix like I did right here. Then I'm fine with that. Okay, so that being said, I'll go ahead and show you using the Gauss-Jordan method how to solve this problem, but you can use elimination instead. So what we want to do first is get a 1 in row 1, column 1. So where 15 is now, we really want there to be a 1 there instead. So that's our first step. So to get a 1 there, we would need to divide everything by 15, or in other words, multiply by 1 over 15. So that's going to be our first step. So 1 over 15 times row 1, and we're going to replace row 1 with that. So we'll have 10 over 15, which is 2/3, 3 over 15, which is 1/5, and 13 over 15, it doesn't reduce. And then the other 2 rows stay the same. Okay. Now we want to be able to zero out the numbers under that 1. So in row 2, column 1, where the 6 is, we want that to become a 0. So we always multiply by the row with a 1 in it. So we're going to do the opposite of what we want to zero out. So since we're trying to get a 6 to be a 0, we're going to multiply row 1 by a negative 6. And then we're going to add that to row 2. And we're going to replace row 2. Okay, so let's see. We're going to do negative 6 times row 1. So that's 1 2/3, 1/5, and 13/15. So let's see what we get when we multiply there. we're going to get negative 6, negative 4, negative 6/5, and let's see, that should be a negative. So 5, so the denominator will be 5 and the top will be 26, I believe, negative 26. Okay, so that's what we get when we multiply by negative 6. Then we need to add that to row 2. So that's 6, 7, 1, 0. So we'll have 0, 3, negative 1/5, and negative 26/5. So that's going to be the new row 2. So we'll have 1, 2/3, 1/5, 13/5, 13/15, and then the new row 2 is 0, 3, negative 1/5, negative 26/5, and then row 3 hasn't changed yet. Okay, so now we want to get negative 6 to be a 0. So that's our next step. So to accomplish that, we will multiply row 1 by the opposite of that. So that's a 6 times row 1 plus row 3. And we're going to replace row 3 because we want the 0 to be there. Okay, so 6 times row 1. So when we multiply by 6, we will get 6, 4, 6/5, and 26/5. And then we want to add that to row 3. And our new row 3 will be 0, 0, 1/5, and then let me see. I think that might be negative. Oh, I don't know. Let's just use the calculator. So we have 26/5 minus 6, and we get negative 4/5. So that's our new row 3. So because we're going to run out of space, I'm going to go back up now and erase this one and start from there. Okay, so now we're going to have 1, 2/3, 1/5, 13/15. Row 2 does not change. And row 3 is now 0, 0, 1/5, negative 4/5. Okay, so that's what we've done so far. So far, we've completed the whole first column. We got a 1 in the very top space, and we got zeros underneath that. The next step is to get a 1, because you want ones along the diagonal. So the next step is to get a 1 here where the 3 is. So we would do that by dividing everything by 3, that whole row by 3, or in other words, multiplying by 1/3. So we would do 1/3 times row 2, and once we do that, that's going to be the new row 2. So let's see. Row 1 does not change. We have 1, 2/3, 1/5, 13/15. Row 3 is going to change. Row 2 is going to change. So if we divide this by 3, that'll be a 1. So we'll have 0, 1. We multiply this by 1/3, we'll get negative 1/15. And if we multiply this by 1/3, we will get negative 26/15. And then the last row does not change yet. Okay, so now we want to get a 0 where that 2/3 is. And actually, you don't even have to do that. What you really want to do, what I suggest doing, is just getting 1s along the diagonal and 0s under. And then once you do that, that's sufficient. You don't have to do the rest. So my next step would just be to get a 1 in this location, this 1/5 to become a 1. So you would multiply by 5 to accomplish that. So we would do 5 times row 3, and we would replace row 3 with that. So let's see what we would get. We would have 1 2/3 1/5 13 over 15. And then we would have, let's see, 0, 1, -1/15, -26/15. And then on the bottom we'd have 0, 0, 1, and then times, because times 5, right? We'd cancel that out and give us 1s. And then times 5 here, that'd be -20 over 5, which is -4. So that would be -4 here. Okay, so this is as far as I would go. If I was going to use the Gauss-Jordan method, I would kind of just modify it to where I'm getting 1s along the diagonal and 0s underneath. And then I would do back substitution. So here, remember that this one represents z equals -4. So at this point I know z. And then I can write equations for the other rows. So the equation for this row is y minus 1 over 15z is equal to -26 over 15. And since I know z from here, I can just plug that in there. So this is going to be y minus 1 over 15 times -4 is equal to -26 over 15. So I'm going to use my calculator here. I can do -4 times -1 over 15, and that's going to give me -4 over 15. Or I'm sorry, it's going to be positive. So y plus 4 over 15 is equal to -26 over 15. And then I would subtract that from both sides. So that's going to give me -30 over 15, which is a -2. So y is -2. Okay, so that gives me y. I found z. And now I can use both of those to plug into the top equation. The top equation is going to be 1x plus 2/3 y plus 1/5 z is equal to 13/15. And so now I know x, don't know x. I know y and z. So I would plug those in. So x plus 2/3 times y, which is -2, plus 1/5 times z, which is -4, is equal to 13/15. And I'm just going to plug that in my calculator and figure out what I get. So let's see, 2/3 times -2. Okay, and then, so that's -4/3. And then 1/5 times -4 is -4/5. So -4/5 plus -4/3 is equal to -32 over 15. So then I would be adding 32 over 15 to this side. So 32 over 15 plus 13 over 15 is equal to 3. So x would be 3. Okay, so now I've found x, y, and z. So I will plug that in above. So x is equal to 3, y is equal to -2, and z is equal to -4. All right, let's erase this so we can see what number 13 is asking us to do. So find all zeros of f of x Enter the zeros separated by commas. Enter exact value, not decimal approximations. Okay, so this one, you're being asked to use your P over Q. I think this is actually one from your previous test, so this is one of the review problems. But you'll be asked to find P over Q. So your P is 11 and your Q is 9. So you'll find all factors of P over all factors of Q. And you'll make a list and then you'll figure out which one works. I would always start with 1 or -1. In this case, you'll see that 1 works. And once you find that 1 works, you'll use 1 for synthetic division. Okay, so I'm just going to, give you an idea of where to start, and then I'm going to leave you to do the rest. You'll bring down the 9. You'll see that 1 works, and then remember this gives you a quadratic. So your quotient gives you now a quadratic that you can solve. So you would try to factor this. If it won't factor, then you would use the quadratic formula to find the other 2 zeros. So 1 0 is 1, and now you need to factor this, or I don't think it'll factor. You'll have to use the quadratic formula to find the other 2 zeros. So you should be getting 3 zeros for that. All right, number 14. Given the system of equations, how many solutions does this have? Okay, so the second equation, I thought it was a mistake, but it's not. It's just x. So the second equation is just x equals -3. So what you would want to do here is look at the first and the third equation and eliminate one of the other variables. So the easiest one to eliminate, so 4x plus y minus z equals -16, and 3x minus 2y plus z equals -5. So I'm going to look at the first and the last equations. If I add them together, the z's eliminate, and I get 7x minus y is equal to -21. And now I know what x is because of the second equation. It tells me x is -3. So I could just plug that in for x and solve for y. So that's what I would do. So this would be -21 minus y equals -21. If you add 21 to both sides, you see that you get 0. So y is 0. And then you can plug in your x value, which is -3, and your y value, which is 0, into one of the other, the first or the last equation. So let's do the first. 4x plus y minus z equals -16. So this will be -12 minus z equals -16. You add 12, so you get -z is -4, which means a positive z is +4. So you found x, y, z. Since you found a solution, it's one solution, and you would put your solution down of -3, 0, 4. Now, obviously, if you get to a point where you find a contradiction or true statement, it would be infinitely many solutions or no solution, depending on the circumstance, right? So just keep that in mind. Okay, 15. I have no idea what all this is. I'm going to ignore that part. So you have a man has $277,000 invested in 3 investments. The first earns 13%, the second earns 10%, and the third earns 5%. His annual interest income from the investments is $22,870, and the amount invested at 5% is twice the amount at 13%. Okay, so let's try to reason through this. So he has one investment. He has 3 investments So X is the amount he invested, the amount of money invested in 13%. Let's say Y is the amount of money invested at 10%, and Z is the amount of money he invested in 5%. So you add up all the amount he invested, he has $277,000 invested. Okay, so then next we know that the annual interest, so remember we're going to assume this is simple interest. So that's principal times rate times time. Since time is 1 year, it's just principal times rate. So we can make another equation with all of the rates. So the principal he invested in 13% is X. So it would be 0.13X, because that's the interest rate for X. It would be 0.10 for Y and 0.05 for Z. So that's the interest he's earning on each of these accounts. And the total interest is $22,870. And then the last equation can come from the very last part. It says the amount invested at 5% is twice the amount at 13%. So the amount invested at 5%, that is the Z, is twice the amount at 13%, which is X. Okay, so we want these to be equal. It says the amount invested at 5%, which is Z. So Z is twice the amount at 13%, which is X. So in order to make these equal, we would want to multiply X by 2 in order to make them equal, right? Because Z has more. So to make them equal, we would multiply X by 2, which would then equal what he has in Z. So this would be our third equation. So you can write it like this, or you can make the variables be on the same side by subtracting 2x from both sides. So you could have negative 2x plus Z equals 0. Okay, so that would be our three equations. Let's see. I'm not sure exactly. Oh, maybe we don't have to solve this one. It's weird because the way it got printed out. No, I guess we do have to solve it. Okay, so these are your equations. X plus Y plus Z equals 277,000. And then the percentages as decimals multiplied by each appropriate variable. And then that's set equal to the interest. And then the last equation. Okay, so let's use these to solve. So on the third equation, we already have the Y eliminated. So if we already have a variable eliminated, we can use the other two equations and eliminate the Y variable there so that we can continue to move forward below. So that would be my suggestion here. So let's look at equations 1 and 2 and try to eliminate the Y variable. So we have X plus Y plus Z is equal to 277,000, and 0.13x plus 0.10y plus 0.05z is equal to 22,870. Okay, if we want, my suggestion is just to move the decimal over one time here, because then that would give us a 1y, and then that would be the opposite of the y above, which is, well, it wouldn't be the opposite, it would be the same. They'd both be 1s, but then I could multiply by a negative as well. So I'm going to start by just moving the decimal over one time. So this would be x plus y plus z equals 277,000. And this would be 1.3x plus 1y plus 0.5z is equal to 228,700. So again, remember this first step, what I did was I moved the decimal over to the right one time. And now I want to multiply, it doesn't matter which one. So let's just multiply the top one. Well, let's do the bottom one. So we're doing everything to the bottom. I move the decimal over one time, and then I want to multiply by a -1. So that's going to give us a negative. I'm going to just change all the signs here. So we'll have, let's do a different color. We'll have x plus y plus z equals 277. That's on the top. And then on the bottom, we'll have negative 1.3x minus y minus 0.5z negative 228.7. And then when we add these together, we'll see the y's cancel out, which is what we wanted. So we'll have negative 0.3x plus 0.5z is equal to $48,300. Okay, so now we have this equation with the y gone, and our third equation that we made that also has the y gone. So we're going to combine those together now. So we have negative 2x plus z equals 0, and we have negative 0.3x plus 0.5z is equal to 48,300. Okay, so let's see. We want them to be opposites. Maybe you're thinking it'd be easier if we just got rid of the decimals altogether. We could do that. So move the decimal over one place to the right. So this would then give us negative 2x plus z equals 0. And this will be negative 3x plus 5z equals 483. So 483,000. Okay, now we need to eliminate one of the variables. So we can eliminate either x or z. Maybe it'll be easier to eliminate z. So here, if we multiply the top by -5, then the z's will be opposite. So we'll have 10x minus 5z is equal to 0. Negative 3x plus 5z is equal to 483,000. If we add these, the z's go away. We get 7x is equal to 483,000. We can divide by 7. So let's see, 483,000 divided by 7 is 69,000. Okay, so x, let's go back up to the top. X was the amount in the 13%. So the amount invested at 13% is $69,000. So that's how much they invested. If I want to know the interest earned, I would multiply that principal, the 69,000, times the 0.13 to see how much is earned in that 1 year. And when I do that, I get $8,970. Okay, so now I've found the amount at 13%, which was x. Now I can use that amount to find z. So let's see what we have now. So this last equation that's circled in red, we can use that because we know x now. So 2 times x, which is 69,000, plus z equals 0. So this will be able to tell us what z should be. So 69,000 times -2 is -138,000. So we would add 138 to both sides, and we would get z is equal to 138,000. So 138,000 is what he invested at 5%, because that's what we represented with a z, was the 5%. And then we would do 5%, So 0.05 times 138,000 to get how much interest. And we get $6,900 in interest. And now last we need to find the 10%, which was y. So I would use my very first equation to do that. So x is 69,000. Y we don't know. Z is 138,000. And that's equal to 277,000. So 69,000 plus 138,000 is 207,000. So now we would subtract 207,000 from both sides, and that would leave us with, leave us with 70,000. So 70,000 is the amount that we invested at 10%. And then again, to find the interest, we would multiply the interest rate times that principal, and we would see that that is $7,000. So that's what you're being asked to do here. So on this one, even though I set up 3 equations, right? So here are my 3 equations. I could have wrote this as an augmented matrix and then use the linear algebra techniques to solve that. But that's definitely not the easiest way to do it, in my opinion. I would use what I just did, which is using the elimination method to solve these. Okay, so 16 is somewhat similar. It's with fewer parts, so I'll let you try that one. 17, Layla and Sterling are running a team relay race. Layla runs twice as far as Sterling. Together they run 18 miles. How far did each person run? So 17, 18, 19, these are all kind of similar to the, let's see, I'm just looking at all these. They're all similar in that they're word problems involving systems of equations. So we did the investment one. Let's pick out maybe one more to do together. Okay, so let's just do number 19. So for this one, it's asking us to write the equation representing the total number of people who went to the museum, and then write the equation representing the total amount of money collected. Okay, so let's read the problem. Admission to a museum is $30 for adults and $20 for students. The freshman class is attending a field trip with teacher chaperones. Mr. Freeze collects $5,390 total from teachers and students, and 264 people total go on the field trip. Okay, so it doesn't tell us how many students or how many adults go. It just tells us the total number of people. So for this total number, we have some number of students, which it said to use an S, and some number of adults, it said to use an A. The total number of people is 264. So we can say S plus A equals 264. Now the total amount of money, if it's $30 for adults and $20 for students, so 20 times S would be the amount of money collected for students, and then 30 times A, because it's $30 per adult ticket, and the total amount collected is $5,390. So that would be the equation for the total amount of money collected. Now you want to solve your system. So you would write down your system of equations, or you could do a matrix, or you could do elimination or substitution. I would probably do elimination. So we'd have S plus A equals 264, and 20S plus 30A equals 5,390. I would want to eliminate the S, so I would be multiplying the top equation by negative 20. So that would give me negative 20S minus 20a is equal to, okay, let's see, 264 times 20, negative 20 is negative 5280. The bottom equation would stay the same. When I add these, the s's will cancel out, and I will have 10a is equal to 5390 minus 5280 is 110. So then I would divide by 10, and I would see that a equals 11. So a is the number of adults. So the number of adults attending is 11. And now we would use that to solve for s. The easiest would probably be in the first equation. So s plus a equals 264. Since we know a is 11, we would plug that in. So we would end up subtracting 11 from 264, and we would see we get 253. So 253 students are attending. So a lot of these are similar. You're going to find an equation for each, kind of part of your system, and then use it together to solve. Okay, one like number 21, you want to make sure that you pick all of the answers that apply. So be aware that you might pick more than one. Since this has 3 variables, you can see 3 variables, that means you probably are going to have 3 equations. So let's go ahead and look at 21 as well. So we have Miranda, Sean, and Heaven go shopping. So these are the 3 people. Miranda buys 2 pairs of socks, 2 pairs of shorts, and 2 sweaters, and pays $106. Okay, so the key is we don't know how much each item costs. So we'll say X is the dollar amount for a pair of socks, Y is the dollar amount for a pair of shorts, and Z is the dollar amount for a sweater. So Miranda, how much is she spending? 106. So 2 times X plus 2 times Y plus 2 times Z, because this is the cost of the socks, the cost of the shorts, and the cost of the sweaters. So her total cost would be 106. So each person is going to have an equation. So let's see, can I find that equation? Yes, here is that equation, B. So this is for Miranda. All right, now let's look at Sean. Sean buys 5 pairs of socks. So let's see, Sean buys 5 pairs of socks, 2 pairs of shorts, and 4 sweaters. And she spends $216. So we're looking for 5x plus 2y plus 4z equals 216. So that's A. So there's Sean. I don't know why there's 2 A's and 2 B's, but it's that A. Okay, and then you would do the same thing for Heaven. You would find her equation, and you would check mark that. So 3 socks, so that'd be 3x plus 5y plus 6z equals 229. So that one would be Heaven. Okay, let's look at number 23. Number 23 is asking you to solve the system of equations with substitution. So for this one, you're substituting in the top one because it's already solved for y into the bottom equation. So you're going to have negative x plus 2y, but instead of y, you're going to put negative 4x plus 6 because you're substituting this in for y is equal to negative 24. And then you would solve it from there. So negative x, whoops, not plus. Distribute the 2, we'd get negative 8x plus 12 is equal to negative 24. Combine like terms, so negative 9x plus 12 is equal to negative 24. Subtract 12 from both sides. So you get negative 9x is equal to negative 36. Divided by negative 9, you get x is 4. So that's the x value. Then you plug that in to find the y value. So y is equal to negative 4 times 4 plus 6. So that's negative 16 plus 6. So that's negative 10. So your answer here would be 4, comma, negative 10 in parentheses because it's an ordered pair. I hope this helps you some working through your review. Take your time. Remember that you want to write all of your steps down for all of the problems, especially the word problems, because I can look and see if there's anywhere that I can give you partial credit. So be sure to write down all of your work on these when you're submitting your work for your test.